Hello, Geography 212. We're going to take a look this week at the weather forecasting chapter in the textbook. So let's just go ahead and take a look at some of the highlights here. All right, just some basic steps in what we do here in the United States for weather forecasting. We need to gather surface data. This is largely collected by the National Weather Service. We gather upper air data, that also collected by the National Weather Service. Then we construct our surface and upper air maps. We'll take a look at a couple of these toward the end of this chapter. We then run computer models, and there are several that we run in the United States. We'll take a look at the global forecast system model here at the end of the chapter. All right. After we do run these computer models, then forecasts get made. I've just listed a few there where a lot of our forecasts come out of the Aviation Weather Center in Kansas City. There's a link to it there if you want to go. The NOAA, which is really the National Weather Service. Now, other agencies will make weather forecasts. You've probably all heard of the Weather Channel, AccuWeather, Weather Underground, but they get all their data from the National Weather Service, okay? The National Weather Service, of course, also forecasts. All right, how do we acquire this data? Well, we have a lot of surface weather stations here in the United States. They're not all operated by the National Weather Service. You can see that. The Federal Aviation Administration has some weather stations, and then private citizens and businesses have weather stations. I have a weather station. We put weather stations up at all our individual campuses at Yavapai College. There are a lot of weather stations out there. And we have buoys out in the ocean that are also weather stations, but they also collect sea surface temperatures, you can see there. So what type of stations do we have? Well, the top here, we've got these automated surface observing systems. We call them ASOS. And we've got almost 900 of these now in continual operation in the United States. And you can see what they report. They report temperature, the air temperature, ambient temperature, dew point, pressure, get altimeter settings, wind direction and speed, precip accumulation, visibility, and a number of other things, including sky condition, okay? We also have automatic weather observation systems, or AWOS. They're very similar to ASOS, and you can see that we have over 1,000 of these. We also have National Weather Service Cooperative Observer Network. These are private citizens who maintain weather records from their location, wherever they happen to be. I used to actually do that myself, did that for several years. All right, upper air observations. These are extremely important. We call them radiosondes. Okay, what happens here is that twice a day, to coordinate with 0 Zulu time, all across the world, places that have the capability will launch these radiosondes. And what they are is they are balloons filled with hydrogen that carry packages of instruments to about 100,000 feet until they burst. You know that the air pressure gets smaller and smaller as we get higher and higher in elevation. And so when we fill these balloons down at ground level, they have a certain air pressure in them, and so the balloon will expand, 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 and finally burst, like I say, around 100,000 feet. The little packages, little instrument packages have a parachute on them. So then these instruments are parachuted down to the ground so they don't hurt anybody. Now, the National Weather Service that does this does not get very many of these instruments back. I happened to attend a launch last year from the Flagstaff area in Belmont, actually. And I was speaking to the National Weather Service personnel there. They say they're lucky to get 5% of these packages back. But you may be out hiking in the wilderness somewhere, come across an odd-looking small instrumentation, and it will say right on there, please return to, and there'll be an address. So they get a few of them back. They can refurbish them, but mostly they do not get them back. So if you look down here in the state of Arizona, you can see that the two locations we launched from, one in Belmont, which is just outside Flagstaff, and the other one down here in Tucson. So like I say, twice a day, happens to be at 4 a.m. our time and 4 p.m. we launch these balloons. And so the data that we get from this is going to be atmospheric pressure at height. We're going to get wind speed and wind direction, and from this information we can construct upper air charts, and I'll show you some of the stuff we can do with that toward the end here. There are other types of forecast. This Hydrometeorological Prediction Center, you can take a look at that. I'm not going to bother going to the link, nor will I go to the Climate Prediction Center. Climate Prediction Center is going to generate these long-term forecasts, these monthly or seasonal forecasts. For example, they recently put out their seasonal forecast for our winter here in the Southwest. And because the sea surface temperature is about 1 degree below normal, 1 degree Celsius below normal in the Pacific Ocean, they're forecasting a weak La Nina event for us. Now, what a La Nina event means for the Southwest for wintertime is generally that we're going to have above normal temperatures and below normal precipitation. And so far, it's certainly panned out that way. We recently set a record high here in Prescott, and we've been well above normal since October here. But we'll see what happens as the winter progresses. All right, so in terms of short-term forecasting, and what I mean by short-term, I'm generally looking at your 5-day weather forecast, okay? There's certain techniques we apply to this, and number one is a persistence method. All that is simply taking a look at yesterday's weather, and it's probably going to be very similar today under certain weather conditions. We'll talk more about that in a minute. Second one is called the climatological method, and that's simply taking a look at your long-term 30-year average temperatures for this date and applying them to that date. For example, today, which is November 19th, our normal high here in Prescott is 59, our normal low is 30. And then finally, the third one is what we call steady state, or just simply using computer models. I'll show you how we can do that sort of thing. All right, so the persistence forecast. Future weather is going to be the same as the present weather. So just as an example, and these are not our normal temperatures, so we've been from about a month ago. So in other words, if yesterday's maximum temperature at Prescott was 68, well, that's what we can expect tomorrow under certain conditions. What might those conditions be? Well, if we're under the influence of high pressure, a large ridge, which we are right now, we would suspect the temperature's probably not going to do the same over the next several days as long as we're under the influence of that same weather system, which we do get a lot here, okay? Same with the minimum temperature. So the persistence forecast will give us the same weather for tomorrow, and we get a lot of that here in the Southwest. Okay, climatological. Like I say, you simply base it on your 30-year average. And if you were taking November 4th, for example, the 30-year average at Prescott's Love Field is 65, minimum 34. We're just going to say the following days are going to have the same numbers. Okay, now obviously we can't do that all the time, but this is going to influence our forecast. Okay, all right, now let's take a look at computer models, how we really do it. I'm going to take you first to this site here. Okay, this is the National Weather Service. They call it the Model Analyses and Guidance. So let me show you how this works, because you might want to do this on your own. All right. When we get to this page, you want to click on Model Guidance. Okay. And now what you're going to see, you're going to get a menu here. The first thing you're going to want to do is NAMR is going to highlight, it just stands for North America. It's going to highlight North America, so click on that because that's what we're interested in. It's going to turn up in red here. Now, we have the opportunity to look at several different computer models that are going to model both the upper air and the surface weather over the next several days. And some of these, you never really know how far they're going to go out. We'll see how far they're going to go out today, but sometimes they'll go out for 2 weeks. Let's take a look at this. This is the GFS. It stands for the Global Forecast System Model, and that's the one we'll primarily use here. You know, we have another one here. This is the North American Mesoscale Model, or NAM. It's really similar to the GFS. You don't really need to go there. We have several other forecast models. The Short Range Ensemble Forecast Model, and this is updated every 6 hours. We've got the North American Ensemble Forecast System. We've got the Global Ensemble Forecast System. And again, that's the same thing there. Now, what you do not have here, now sometimes if they're not highlighted in dark blue, they're not available right now. But sometimes we do not have access here to the European model. And the reason I bring up the European model, that one has been selected as the most accurate weather forecasting system in the world today. So much so that the United States Air Force has ditched the global forecast system and now is using the European model. You know, for right or wrong, like it or not, because it's proven to be more accurate. They just simply have a bigger supercomputer. They've got more data that they work with. Anyway, let's go ahead and click on GFS. And now we get another menu here. Now, if you look along the left, you'll see precipitation parameters. We'll look at those in a few minutes. Surface layer parameters, upper air parameters. This is what we really are interested in. Let's go over to 300. What the 300 is going to do is it's going to give us the winds at 300 millibars across North America. So I'm going to click on that, and you're going to get another big table here. Now, what do these numbers mean? 000 means right about now. 1 is 1 hour from now, 2 hours from now, so on and so forth, up to 24 hours. So there's your first day. So you can see through the first 5 days here, they're going to give you a new map for every hour. And then as we get beyond 5 days, you're going to get a map every 3 hours. And then you get beyond 10 days, you're going to get a map every 12 hours. So let's just click on the 000 and orient ourselves to what you're seeing here. Okay, so this is a 300 millibar chart. Remember, that's going to be up around 30,000 feet. And if you look down here, you can see the state of Arizona. Now, the color coding here is for wind speed. The darker the blue, the faster the wind speed. And when we get to the dark blue, we're at over 100 nautical miles per hour. So the blue really is in there to show you where the polar front jet stream is as we follow it along. And you can clearly see the troughs, the ridges. Let's start out here in the Pacific Ocean. We have a trough, so it's a trough of low pressure out here. It's going to be pretty stormy weather there. We have a ridge of high pressure here that we're under right now, giving us this gorgeous weather here in Arizona. We have a trough pretty much near the Great Lakes, over the Great Lakes area. We have a ridge over the East Coast, and embedded low. It's getting kind of complicated out there. So we got a trough, a ridge, a trough, a ridge. Very much meridional flow going across at least a central and northern part of the United States, really all the United States right now. And this is the kind of thing you start expecting in the wintertime. So anyway, right now then the upper air, we see that we are in a ridge here in the southwestern part of the United States, and we would expect to have fine weather, and we do. Now, remember, this is for forecasting. So the computer model, we're going to go back. The computer models will model us into the future. They'll go 1 day in the future, 2, 3, 4, 5, 6, all the way up to 16 days. Now, I doubt the accuracy of a 16-day upper air forecast, but I will tell you this. Over my experience over the years dealing with this, we do pretty well at forecasting our upper air to at least 5 days. We do pretty well. The upper air turns out to be easier to forecast than surface weather. So let me show you a feature you can do is loop all. And now, there you go. It's going to give you a moving picture of what's going on. If you look down here, look at that number. That's how many hours we are, 12, 13, 14, 15, into the future. So you watch that number and watch what's coming into the southwest. You can see a trough approaching us. So that's going to be a low pressure system and a cold front associated with it. We'll see it on the surface here shortly. But you can see this, the global forecast system model is forecasting 48 hours we just hit. Within 48 hours, we should feel the effects of this as that trough passes through the southwest. Now, after that trough goes through, you can start seeing a bit of a ridge building out in this area approaching us. So it looks like now we're 76, 77 hours out. A ridge or nice fine weather will build back in behind the trough. And then you can see they're forecasting yet another trough to approach us from the northwest. So it looks like, over the next week or two, at least the next week, we are going to be hit with some progressive troughs approaching us from the west and the northwest. And now we're out to 120 hours, you can see as that trough moves in. Now we're into the 3-hour increments. You see how the hours are jumping up there. And I think I'll knock it off there. Let's go back. Okay, so just from that upper air chart from the global forecast system, we can see that we should have pretty good weather for another 24 to maybe even 48 hours. But within 48 hours, we're going to feel the effects of the trough. Going to get colder, cloudy, maybe even some rain. Now, speaking of rain or precipitation, let me go back and show you what I did. So we're back here at the main chart. And now we want to go up to precipitation parameters. And you can click on Precip 03. And what's going to show you here now, let's just go to 03. Okay, now we're going to look at surface weather. The green is precipitation, color-coded to intensity. The light green is fairly light. You can see as it gets to blue here, right up here in, say, Northern California, you go over here, that's going to indicate, heavier rainfall. That's in inches over there, how much precip. Just like the upper air, we can put this into motion. So let's go back and let's put it in motion first. It's called loop all. And we watch down in Arizona. You can see some precip approaching and then some developing, yes. So you can see that in the surface model is also suggesting as that trough moves through in about 48 hours, we're going to see some surface precipitation. And I've already read the forecast model discussion. It indicates a pretty warm system coming in. Doesn't look like we're going to get any snow from this here, at least here in Prescott. Looks like it's just going to be a rain event. Now, let's run this one back again. So I'm going to show you another thing here. You can look down here hours from now. See 21, 27, 30. And so you can see, let's just stop it. You can see that we've got a lot of precipitation showing across Arizona 57 hours from now. Now, if you really want to pinpoint that, you can go back. We can, let's see, we go previous. Too bad I can't see Arizona and previous at the same time. Let's just to see when this precip starts. Okay, well, they're showing, let me forward it just a little bit here. Yeah, that's not the main area of it yet either. Okay, certainly there. So there, you see, it's 48 hours. So this is all looking like it's going to start happening 48 hours from now, so 2 days from now. So that would be on a Monday, maybe even Sunday night. We could see some precipitation entering into Arizona. So that's the precip part. So just an absolutely wonderful source of information here. These are the same models that forecast agencies like the Weather Channel, like AccuWeather, are using to predict weather. You should use these tools yourself to take a look at that. Now, I want to show you something else here. Not in this site. We're going to go to another site. This site here. And what this site's going to show us, it's going to do some forecasting for surface features. So here's the opening page, National Weather Service, National Centers for Environmental Prediction. But really what it is, it's this one here anyway, is surface forecasting. Click on more of these products. And they've really updated this recently. It's pretty nice. So this is forecast again. So the first one, just simply hover your cursor over the first. Second one will make it move. Third makes it move. All you got to do is move it over and it'll move it. But let's start here. Okay, remember we looked, the upper arrow was showing us a trough approaching us from the west coast. Well, look at this. There is a surface feature, cold front, and a lot of precip. This color stuff, the color coded for precip and precip type. Okay, so the green is going to be rain. You can see down here the blue is snow. So we're seeing a mixture of rain and snow moving into the Pacific Northwest, Northern California with an associated cold front. Now these are in Zulu times. There's 8 hours ahead of us right now. So if we bump it up 6 more hours, we see things are getting a little closer to Arizona. Okay, let's bump it up another 6. We see we start getting precip showing up in the Colorado River Valley right down in here. Bump it up another 6 hours. We start picking up some scattered precipitation out ahead of the cold front in northern Arizona. And now by Monday midnight Zulu, which is going to be about, that'll be the afternoon time, late afternoon Sunday, they're showing we should start picking up some precipitation in Arizona. Okay, so according to this then, we're looking at about 4 or 5 p.m. Sunday afternoon is when the forecast model is predicting this. And as we continue on, heavier rain approach coming in. Now you can loop this as well. So this is over a 2.5 day period. Just going to keep looping back and forth so you see the progression of the surface features as they come in. Now, unfortunately, they only do this scale at a 2.5 day interval. So let's go back. So if you wanted to do a 5-day forecast, for example, you would have to go back and then do more of these products. You can see over here day 3 to 7. By the way, all of these maps you can look at individually that we just looked at. You can see there's 6-hour intervals up to 60 hours from now. So that's 2.5 days. So if you want to go beyond that, you got to click on, actually, let's go with more of these products. And just scroll down, click on day 3. And now you see you don't get the kind of detail, you don't get the precipitation forecasting here, mainly because we're not good at it beyond 2.5 days. But you are going to get surface, this is all surface stuff. So you're going to get surface front, surface low pressure, surface high pressure, and that sort of thing. So this would be day 3 from now. And the one nice thing on here, you can just click to go to day 4. Let's do that. You can see we got that second. Remember when we were looking at the upper air chart, we saw a trough approaching. It's going to come in about a day and a half. Then we saw another one. It looked like it was about 4 or 5 days out. And here is the surface cold front associated with that. If we go to day 5, looks like it really hustled through. So it looks like we are going to get another system coming through in about 5 days. You can take day 6. You can see yet another cold front approaching us. This is not unusual for this time of year. You remember, we're getting into late November now, and you know that the sun has sunk pretty far south of the equator. All of those 4 zones we talked about earlier in the course, polar high pressure, subpolar low, subtropical high, and the ITCZ, all of them are moving south. So we're starting to get hit more by the subpolar low pressure zone. We're getting kind of one after the other, having some effect on the weather down here in the southwest, and that's expected. The southwestern part of the United States gets its maximum precipitation in the winter. We get about 60% of our precipitation during the wintertime from subpolar low pressures. Subpolar low pressure systems. The remaining 40% comes from the summer monsoon season. Okay, so there you have it. There's just a quick introduction to some of the computer models that you have free access to on the internet. So go ahead, I strongly urge you to go ahead and use that. Click around in there. There was a lot more stuff you can access there than I showed you. But the global forecast system model is one of the best we have. So I'd say, if you just stay with that, you can do your own weather forecasting. All right, that's it for today. See you later.